Hi everyone. Today we're going to study binomial probability distribution. Let us define binomial experiment. A binomial experiment is a probability experiment that satisfies the following. Number 1, there are only two outcomes, namely success or failure. Number 2, there must be fixed number of trials. Number 3, the outcomes of each trial must be independent. Number 4, the probability of success remains same for each trial. For example, tossing a coin, the outcomes are head or tail, is a binomial experiment. It means this experiment satisfies these four conditions. The probability distribution of a binomial experiment is called binomial distribution. Probability formula for binomial distribution. In a binomial experiment, the probability for exactly R success in n trials is this. P of capital X equals R equals combination of n taken R at a time times P raised to a power R times Q raised to a power n minus R. Take note, the P is equal to the probability of success, and this Q is the probability of failure. And the formula for Q equals 1 minus P. Take note also that the mean is equal to this symbol E of X, which is the expected value, and this is equal to N times P, while the variance denoted by var of X equals N times P times Q. Let us see this example. Identical computer components are shipped in boxes of 5. About 15% of components have defects. Boxes are tested in a random order. What is the probability that a randomly selected box has only non-defective components? For our solution, let us list the given. Take note, we let capital X be the number of non-defective components in a box. The n is equal to 5. Given here is the Q, or the probability of failure, and that is 15%. And we write 0.15. From Q, we can compute for the P, and this P is the probability of success. The formula is 1 minus Q. Substituting the value, we have now 1 minus 0.15, and the P equals 0.85. Again, P is the probability of success. The formula is here. Again, we say that X, that is the number of non-defective components in a box. So, the probability of a box with 5 non-defective components is, it means the R equals 5. Substituting the corresponding values in this formula, we have now P of the capital X equals 5 equals combination of 5 taken all at a time times the P now is 0.85 raised to R, and that is 5, times the Q, which is 0.15 raised to N minus R, and this is 5 minus 5 in the power. Simplifying further, we have this 5 combination of 5 equals 1. We keep the 0.85 raised to 5 the same, and the power 5 minus 5 here is 0. We can simplify further because the 0.15 is raised to 0. We can make this also as 1. And the final answer for this is 0.44. This is the probability that a randomly selected box has all non-defective components. This is our final answer. I hope you learned something from this video. See you again next time.